Hello there and welcome. So in this video, we will look at object detection using pre-trained YOLO V8 model. YOLO V8 is already trained on Cocoa dataset. So how do we do an object detection? It is really simple. From a bird's eye view, any object detection code will have three basic parts in it. The first one is load the model, second one is load the image, and third one is do prediction on top of that image. Very simple, isn't it? In our case, the model which we are going to use is YOLO V8. An image in whatever image format you are comfortable, you can use. It can be either PNG, JPG. That's it. Super easy. Now let's understand how do we do it practically. Let's try to use YOLO V8 on top of an image and let's see how we can detect an object in an image. But before that, let me show you the image on which I'm trying to run the inference. So here is a sample image. Basically what I'm trying to do here, I am trying to detect all the person in this image, and let's also see whether we can detect this small object football here or not. Of course, this is a pre-trained model, so we did not need to have an extra data to train our model. So let's jump into our coding part and start coding. But before that, again, we will be needing two libraries. One is OpenCV for Python and another is Ultralytics. If you have not installed these libraries, here is the command to install it. Just open your terminal and paste these commands there: pip install OpenCV and pip install Ultralytics. It will install the recommended libraries for you. Let me delete it first, otherwise it will reinstall again. Now, once I have all the libraries installed, let's import it. Now, since we have both the libraries imported, let me try to save the path of the image on which I'm trying to run the inference. So let me copy the path from here, copy path reference, and there you go. So this is our path for the image. Let me give the proper folder structure. Now let me try to load the model. So model is equal to YOLO. We will be using YOLO keyword from Ultralytics to load our model. So what is the name of model we are trying to load? So we'll have to supply the exact name of our model here. So how do we know the exact name? The moment you will run this code, it will download that model from web, and this is the name of the model file, YOLOv8.pt file. So since I have run this file earlier, that's why it has downloaded it in my folder. If it's not in your folder, don't worry. The moment you will run it, it will download it and keep it in the same folder for you. So let me load it for you. Let me copy this. It's easy that way. And there you go. We have loaded all model. So next step, what we need to run inference on top of our image. So let's create a variable result. And we will be using predict function from YOLO. So we'll be trying to predict model dot predict. What we are trying to predict, we are trying to predict on top of this. So we will say source is equal to, this is the path on which you will have to do the inference. By inference here, I mean the detection basically. So we have all the results inside this result folder. Now let's show our results. So this is how we are going to do it. We are using a for each loop here for result and results result dot show. My typing speed is pretty bad today. So let's run it and see what inference is done in 17.2 millisecond. Okay, perfect. So here we have 1, 2, 3, 4, 5% detected. There is one more person is amazing. This is an amazing accuracy of YOLO. And we are able to detect also this small sports ball here. All right, so this is quite perfect. Now let's do one thing. If I want to detect only the sports ball in that image, this is how I'm going to do it. So I will supply the class ID of that exact class which I'm trying to detect in that image. So our ID for football is 32. How do I know ID for football is 32? Now let me try to first print all the IDs for you so that we are more comfortable. So let me just delete it for time being. Let's print all the names inside our result. All the trained classes inside my result, it will be in the form of dictionary. So let me comment this one also, and let me try to run it again. Okay, so here is our all the trained classes on which this model has been trained. So 0 is for person, 1 is for bicycle, and here is our sports ball here. And this is what we are trying to detect. So idea is that we are only trying to detect this sports ball in this whole image. And if we supply this ID here inside this, if we supply this ID inside this predict class, it will only try to detect whatever ID is supplied here. So now let's supply it here. Class is equal to 32. Perfect. We can supply multiple class ID here, but since right now we are only trying to predict sports ball, so let's give only sports ball here, and here in result we will show result.show. Let's run it and see. Perfect. You see we have bounding box only around our sports ball. Quite amazing. So this is how you can have a bounding box around only a particular object, and else other object will be rejected. A notable advantage here is in terms of processing time and inference time. If we are trying to concentrate only on a particular class, our processing time and inference time is really small. So if at all you have any use case in which you have to detect only a particular class, this is the way you can move forward. So this is it on detection on top of an image. In next video, we will talk on how we can detect images on top of a video. So there are millions of use cases out there where a object detection on video can be applied. So see you in next video, guys.